Hi, this will be part one on the introduction of exponential growth and decay. So I would like to introduce to you a couple of formulas or functions. And at initially, you're just going to be writing the functions, but eventually you're going to have to solve for those functions. So if you see something that has growth in it, you're going to see words that are synonymous to it. So, like increase, grow, appreciate. It just depends what the scenario is referring to. The formula for exponential growth is as highlighted. A of t, because it's a function, is equal to p times the quantity of 1 plus r, all raised to the t power. And what each of those variables represent are shown to the side. So A of t is typically what you're trying to find, and that's the population or the amount that's after the time that's given. So for instance, what will the population be after 5 years? So that would represent your A of t. That's what you're trying to find. P represents your initial population or your initial amount. So it may, sometimes they'll use that word initial. So it's a dead giveaway that P is whatever follows initial. So if you see initial population is 300,000, that's going to represent your P. So then R, now this one sometimes is presented as a percentage. Well, in order to use it in the formula, you're going to have to convert it to a decimal, okay? And also pay attention, this is the growth rate. Sometimes that word will change when it's referring to a rate, so pay attention. That way you'll know which formula to use. And growth is going to have a plus sign, so that's helpful also to know. So I showed you an example of if they gave you a percent, like 2%, you want to convert that to a decimal. Some people don't know how that works, but think of percent. Percent means 100. So how many zeros are in 100? 2. So I'm going to take my decimal. If I'm given 3%, it is understood that the decimal is after the number. And I'm going to move it 2 places to the left. So that will be 1, 2. That's my new decimal. And then since there's some space here, I'll just fill in a 0. When I have a decimal, I want to go ahead and get rid of that percentage. So in my example, I started off with 3%. The decimal form of 3% will be as follows, 0.03. And I just showed you here how I came about with that decimal amount. Okay, so the next item or variable that's shown in our formula is t, which represents time. So basically, how long will it take to get to a certain point? That's what you're looking for. As with any word problem, you just have to dissect it and look for specifics. So let's get started. It says the cost of a chocolate bar in 1962 was 5 cents and was increasing. So I see increasing. That tells me I'm going to use the exponential growth formula, which has a plus sign. And it was increasing at an exponential rate. Well, rate is R. So if I were you, I would just go to the side when you're actually solving and write down like R equals, or I mean, because that jumps out. So R equals, and again, this is shown as a percent. You can't leave it as a percent. When you're using a rate, you're going to have to change it to a decimal. So as I was writing, sorry. So R would not be 8.7%. Using the method I just told you, you move your decimal over 2 places. So if it's already after the H, you move it over 1, 2, and then you place it there and put a 0 in front and do not use the percent sign anymore. So it would be 0.087 for my rate in this example. All right, so what it's asking me to do is write a function to represent what I just read. So my function is not trying to solve anything. It's just what would be the function that you would use if you were trying to solve it. So what I am going to do is recognize that A of t is what I would have been trying to find if they asked me for the population after a certain time, but they didn't. So you know what, before I do that, let's go back, and we already said that rate is 0.087. So we know we have R. We just have to try to figure out what that is, because that's the only other given information. It says that the cost of a chocolate bar in 1962 was 5 cents. So if I'm looking at all of my options over here, Well, we know it's not rate. Well, it's not time because it's asking time is more like how long will it take? So we know it's not T. We know it's not R because we already have our R. And we're not trying to find the amount after a certain time. So by default, the initial cost. So they're not going to always use the word population or amount. The initial cost was 5 cents. So that means I have my P as well. And I don't have to convert that. Whatever they gave me, that's what I'm using. So I'm asked to, sorry about that, I'm asked to actually write a function. So when I write this function, it is going to still use A of T. And now I'm filling in my P, which I just said was 0.05. My formula tells me to use 1 plus, so that doesn't change. And now I put in my rate, which is 0.087. And I was not given a time, so I'm just going to raise it to the T power. For this particular purpose, where it said to write a function, I am finished. I substituted in the two givens, and then I just wrote the function of what I would actually use if I had more information. Okay, moving on to the next one, which is very similar, so you have to pay attention to the words. This one says exponential decay. Well, decay is synonymous with these words. So you might see decrease, you might see the word decay, depreciate, or eliminate. So those are just some words that you may see. The only difference between the two is this sign. Decay means you're deducting or you're subtracting, you're losing value. Everything else is the same over here, except for, like I said, the rate is no longer saying growth rate, it's saying decay. So pay attention to that, and you are still going to change your percent if they give you a percentage to a decimal. So let's work on this one. The scenario says the value of a new car bought for 23,400 decreases. So that tells me I'm going to use decay because I am subtracting or I'm going down. So it decreases 5.7%. If it's given as a percent, chances are that's my rate. So I can go ahead and to the side and write, well, I know that R is going to equal, put this in decimal form, 0.057. Do not keep it in percentage form. So it decreases 5.7% every year. Write a function to represent this scenario. So again, the only thing you're trying to figure out is, well, what does that 23.4 represent? The value of a new car bought for. So that means the initial amount that I bought it for is going to be 23.4. So again, P represents that number. Do not get it confused with A of T. A of T is what will it be after a certain amount of time. So how much would that car cost after 7 years? That's what A of T would represent. So if I am writing this as a function, I would again use the information for the exponential decay, and it would be A of T is equal to, fill in what I know. I know P is 23,400. The formula tells me to use 1 minus this time. So times the quantity of 1 minus. And then R is represented by that 5.7%, but I have to write it as a decimal. And then I take that value and I raise it to the T power. So I'm just following my exponential decay function. That's all I'm doing based off of what my directions asked me to do. And then finally, sometimes you will see something called HalfLife. HalfLife, again, it has the A of T, it has the P, and it has the T. But this time it doesn't have a rate. It has an H, which stands for half-life. So when you are trying to determine if you're going to use half-life formula, 9 times out of 10, it will actually have the words half-life in it. So if you see that, this is the formula that you're using. So A of T is still the same, P is still the same, T is still the same. The only thing that you see different is this time, instead of 1 plus or 1 minus, you actually multiply your P times half, which is 0.5. And then also on the outside, instead of just having your T as your power, it's actually T divided by H. H represents half-life time. So when you are going through and you're looking at your actual wording, look for half-life. Half-life is 28 years. Okay, so now to the side, you can just go ahead and write, well, H is 29.8. I do not have to convert it. Whatever is shown is what I'm going to use. Then I see the word initial. So that tells me, oh, that's going to be P. So initial mass of the sample is 1.50 kilograms. So again, I have more information. I have P, 1.5. I'm just going to put 1.5. All right, and now I'm asked to write a function, but I see another number, so I can't just start writing. Pay attention there. I see another number. It says write a function which will show how much will remain after 123 years. So if I were trying to solve this problem, how much would remain after a certain time is what I'm trying to find. So what's given here is the time that the T. So I'm looking for, and time can be in years, months, hours, it doesn't matter. Just pay attention to that as well. So I know T is represented as 123 years in this problem. So now I just go back to my half-life formula and I fill in what I know. I don't know my A of T. That's what I was trying to find. I know that P is 1.5. It's multiplied times 0.5 based off of the formula, and all of it is raised to T over H. T is 123, and H is 29.8. So the last thing that I do want to advise or say to you is when you are actually, if you were trying to solve for A of T here, make sure to put it in a calculator just like you see it. Do not try to multiply these two first and then raise the whole thing to this power, because it's going to give you a different answer. If you put it in a calculator like this, the calculator understands you only want to raise this portion to that power. Okay, so hopefully that was helpful to someone. You already know the routine. Like, subscribe. Have a great day.